Hello, Algebra 1. We are back at it this time to review the Quadratics and Parabolas chapters, which are sections 9.1 to 9.4. I want to make sure when we're going through this section that you all realize that you need to be able to do all the types of problems that I'll be showing you. I'm going to go over the notes first, and then I'll go back through in a separate video and do some example problems for all of the different sections that are there. So the first one this morning, as we're going through, you should see the standards for this unit are quite plentiful. When you're looking through, you'll notice that it talks lots about graphing and looking at quadratic functions. And as soon as I say the word quadratics, you better be thinking in your head, oh yeah, that's the ax squared plus bx plus c. So we're looking through to be able to solve them, be able to graph them, and be able to use technology to come up and look with the graphs. So the first thing that I want to talk about today, I'm going to go ahead and slide myself up here. You'll notice again this icon in the corner. If this is already in your notes, then you don't need to worry about writing it in again. If it's new and you don't have it in your notes, or you look at that and think, oh my goodness, I have no idea what that is, then you probably should write it down in your notes again. So you'll notice that the first thing we're talking about today is the quadratic function. Quadratic functions are always in the form y equals ax squared plus bx plus c. Now remember, as we're going through there, the a can change and be any number, the b will change and be any number, and c will again change and be any number. You'll notice in this first example that we have just 3x squared. It's a quadratic because it has an x squared, but you'll notice both the b and the c are 0, so we don't write them in there. The next one, we can see again y equals ax squared. As soon as we see that x squared, we know it's a quadratic, plus 9. In this example, the b is a 0, and with the b being a 0, then that means that we don't write either the b or the x, because 0 times x is 0. The last one here is kind of the most standard way that we see it. We've got y equals x squared minus x minus 2. And the only confusion I expect someone might have in this one is recognizing that the x squared has a 1 in front of it, and that the x here has a coefficient of -1. A general graph, you'll see whenever we're dealing with quadratics, our parent graph here is this parabola, and that's the standard graph y equals x squared. You will always get a parabola when you graph an x squared equation. So moving on next, when we're talking about parabolas, we need to make sure that we know the vocabulary that are around them. You'll notice that down here at the bottom, you'll see the vertex. It's right there. In some parabolas, that's the minimum point. In other parabolas, it's the maximum point. But this is a crucial point when we're talking about parabolas. We also at the same time know that through that vertex goes the line of symmetry. And this is that symmetrical line where you can imagine if we folded the graph in half, it would be an exact copy of itself on both sides. Along with those intercepts, along with that vertex and line of symmetry, we also have our x-intercepts. You guys will remember this is the x-axis. And so the x-intercepts are the points where that graph crosses the x-axis. And yes, it's true, there are some equations that do not have x-intercepts. If you can imagine, sometimes the graph will sit up above the x-axis, and that means that it won't in any space cross that axis. And then lastly, not talked about quite as often, is the y-intercept, and that's of course where the parabola crosses the y-axis. Okay, so on this one, there's another video that shows you a whole bunch of fun ones playing with equations, but this one is just the basics. You need to be able in your quiz to look at an equation and know what it looks like. So the first one is our y equals x squared. That's our regular parabola. However, if that coefficient in front of x squared is a negative, then our parabola flips. It's essentially an upside down parabola. So you'll see on there, this would be a negative x squared, And my vertex now becomes the maximum point instead of here where it's the minimum point. Then also, as we're looking at those, I can change the coefficient on the front of my equation, and that changes the width of the parabola. The smaller the number, or the closer it gets to 0, the more flat the parabola becomes. It becomes a wider parabola, closer to the horizon or the x-axis. And the larger that number gets, the tighter that parabola gets to the y-axis. So smaller numbers get closer to the x, larger numbers get closer to the y. Now, in this section, I'm not going to walk you through these right now, but I gave you an example. You must be able to graph a parabola by making a table of values and plotting them on a graph. So you can see our example here. We are given our parabola, y equals x squared plus 4x plus 3. And then the person doing this problem went through and chose the values from -4 to +2. Remember, when you're graphing a parabola, you should not only use positive numbers. Make sure that you use positives and negatives both, because we need to see both sides of that line. If you're confused about how they got these numbers, I'll tell you they plugged x in for x in the equation, and then they solved. So this would have given them, I'll give you just a quick example. This one here would have given them 0. Let's see if I can get it. Yeah. Mouse drawing is not always my strong point. 0 squared plus 4 times 0. Remember, that's a times in between. So 4 times 0 plus 3. So when they did that, 0 squared is 0, 4 times 0 is 0, and they were left with just 3. So you can see their y value was 3. They then went back through and did the same and plugged 1 in for x and got an answer of 8. In the additional videos, I'll go through and show you guys how to do that if you're confused on it. But you should be able to create a table of those values with 4, 5, 6 points in them to get a good parabola, and then be able to plot that onto an x and y coordinate grid. At the same time, you need to be able to accomplish the exact same thing with, sorry guys, I couldn't get my pen to turn off. Did it go away? No, not yet. Okay, you should be able to accomplish the exact same thing with a graphing calculator. So I left you a YouTube video here that shows you how to go in and graph an equation using a graphing calculator, and then I'll also show you one. Actually, this video is good. I'll use a program called Desmos in an additional video to go ahead and graph them, but it's the same process no matter which technology you're using. Okay, so here's where it starts to get a little bit more complicated. There's some great examples that I'll walk you through in the additional problems, but here are just kind of your notes. You need to be able to find an axis of symmetry when you're taking this quiz. So to find your axis of symmetry, what you're going to do is use this equation here, which is -b over 2a. And remember, the b comes from here and the a comes from here, those coefficients. That will give you the axis of symmetry. And then you also need to be able to find the coordinate of the vertex, and I'll show you guys down here how to do that one. So in this one, again, I'm kind of pointing as I go along. I'll work out another example later on in a different video. So here, when you're going in, you've got y equals x squared minus 6x plus 4. So in this example, the a value is 1, the b value is -6, and the c value is 4. In order to find the axis of symmetry, I just plug those into that equation. So you can see my b comes right in there and goes negative b. And then on the bottom is my 2 times a. A is right here. So 2 times 1. So -6 is 6. And then 2 times 1 is 1. 6 divided by 2 is 3. And what that tells me is if I have a coordinate grid there, my axis of symmetry, where my parabola folds over, if you will, on itself, is along this x equals 3 line. This will be that line where the parabola, along the center of the axis of symmetry for the parabola. To find this vertex point, I have to figure out where's my parabola sitting here. Where's its vertex? So in order to do that, I use the x-coordinate of the vertex again. So you'll see that's the negative b over 2a, which was at 3 right here. So I know when I'm looking for my vertex point that the x value of it is 3. I then need to go in and solve for the y value. So since x is 3, we plug 3 into that same equation that we have in place of x. So we're going to plug a 3 in here and a 3 in here, and we're going to solve for y. So you can see I plugged in 3, and for my x, plugged in 3 for my other x, and then the 4 stayed the same. So 3 squared was 9. Negative 6 times 3 is 18, and then the 4 is there at the bottom. 9 minus 18 plus 4 gives me an answer of negative 5. That means the y-coordinate of my vertex is at negative 5. So when I'm building my graph here, it's a very fancy graph, I know that my vertex point is going to be at 3 and then down to negative 5. So when I'm building this parabola, I know that it's going to either face upward or downward, but the vertex is going to be here at 3 and negative 5. Now really, I can look at this and say, okay, well, as my x value, or my coordinate for a is a positive number, so I know that this thing is going to open upward. Right? And in the next section, we'll learn to solve for these 0 points, and then we'll be able to graph an entire equation just using that axis of symmetry, the coordinate for the vertex, and then whether it opens upward or down along with the zeros. Okay, on the next one, here we are talking about those zeros. The best questions you guys can get out of these are when they just turn around and ask you to read the zeros right off of a graph, right? So the zeros or the solutions or the x-intercepts are where this crosses that x-axis. So if I were reading the zeros off of this graph, I could turn around and say, okay, that one's at 0 for x, or excuse me, 0 for y, and then my x value on that one is negative 1. I wish I was fancy enough to find my eraser, but I haven't. So that one's at negative 1, 0. And then this one here is also at 0 for y, of course, because it's the intercept. And then the x value is 2. So if I were using a graph to find the zeros or solutions or x-intercepts, they're all the same thing, I could read them straight off of that graph of where that parabola crosses the x-axis. So now that's one way to be able to find the zeros, is by going through and using the graph. Well, then I want to change my pen to a less cranky color. Okay. Outside of that, we can also use the straight up equation to be able to find the zeros. And when we do that, the first thing that we have to do is factor. So if we're factoring an equation, we know that we need to get in this form, right? So one unit times another, right? One binomial times another to give this answer. So when I'm looking here, I personally just like to rewrite my equation, x squared plus 8x, oh, this is some delightful handwriting, plus 15 equals 0. You guys remember we're using that FOIL method, firsts, outers, inner, lasts. And I like to write it like this because we're using it backward. So in order to get an x squared in the first space, I know that the only way I can multiply my firsts and get an x squared is by multiplying x times x, and that will give me an x squared. It's the only way. Now in this part, when I multiply my lasts, I need to get 15. So I have some options here. I could use 15 and 1. I could use 3 and 5. And then I also could use the opposites of those. I could use 15 and 1 or 3 and 5 on this side. So I'm just going to write them once. The issue is I need them to add to 8. So when I look at these two options, I can see 15 and 1 are going to add to 16, and 5 and 3 are going to add to 8. So this becomes my best choice. So that means that the first trinomial here is x equals 5, or excuse me, binomial. The second one is x equals 3. Let's see if I can find my fancy eraser. Oh, I'm so excited. Look at that beautiful eraser. Okay, so now when I go through here, I can solve. I know that one of these two has to be equal to 0. Remember, I'm looking to find the zeros or the solutions of my parabola. I want to know where it's going to cross this x-axis. So I need to solve for 2 points. So when I'm doing this, I know that one of these two, or both, have to equal 0. So I can make this x plus 5 equals 0, or x plus 3 equals 0. That's a really bad equation sign, I'm sorry. I might have to go back to the whiteboard later. So in order to solve this, I need to subtract 5 on both sides, and I'll get x equals -5. And on this one, I'll subtract 3 again, and I'll get x equals -3. And what that means is when I'm graphing here, the two places where this parabola crosses the x-axis are at -3 and -5. So when I'm drawing this, this parabola has to go through here. Remember in the last slide I showed you how to use your A and B coefficients to be able to find the axis of symmetry and the vertex. And then that would allow me to be able to draw the whole graph. Okay, there was a lot of work in there. The last piece that's in here that you'll need is to be able to go backward from what you just learned, which means that you're now given the solutions and you need to make the equation. So if we think about this, you're given this endpoint, right? You're given where we started, where we just ended at the x equals -3 and x equals 6. And then we need to go forward to come down and get our quadratic equation. I'm getting better with this pen. So in order to do that, the first thing we need to realize is when we set each of these equal to 0, we're going to add 3 to both sides, and that this term would then become x plus 3. Remember in that last step, we split each of these equal to 0 and solve for x. So we're kind of running that backward now. And over here, we'd do the same. We'd move the 6 to this side by subtracting 6. So my second term would become x minus 6 equals 0. And then in order to get to this equation form down here, we're just going to go ahead and use that FOIL method. First, outers, inners, lasts. So x times x is going to give me x squared. I always like to do the inners first. X times -6 is -6x. 3 times x is plus 3x. And then 3 times -6 is -18. And now you can see we need to add these middle terms together because they're both x's. And I'm left with x squared. And then -6x plus 3x is a -3x. And then I still have -18 here at the end equals 0. And what I want to show you is something a little bit different there. So if you see here, my equation that we came up with is x squared minus 3x equals 18, or excuse me, minus 18 equals 0. And it said that my solutions were negative 3 and 6. So I'm going to go ahead and pull Desmos over here. And I'm going to graph an equation in here. And you'll realize that my answer was x squared, right? I had minus 3x minus 18. Let's make sure that that's what we had, right? Yep. Negative 3x minus 18. So when I graph this in Desmos, and then I go ahead and pull my graph out, what we're looking for is right here, the intercepts, or the solutions. And you can see that the solutions on this graph are at negative 3 and at 6. So just exactly like we had seen in our solutions, right? They're at negative 3 and 6. Okay, so that was probably the most intense part of all of this. The last one that we're looking for is this piece right here, which is the x squared equals k. And it's kind of actually a shortcut, if you will. The x squared equals k is a way of not having to go through the whole process of solving an equation, but being able to just kind of walk through it and have an answer faster. Hold on one second, let me switch back over to the graph. So I wanted to show you guys on this one, remember that we're looking for the solutions of a graph, so we're trying to see where it crosses that x-intercept. And sometimes we don't have a middle term. So for example, we could have x squared minus 9. And you'll see that there's no middle term here. But what's interesting, if you look at it, is that the zeros, or the solutions, are at 3 and 0, and negative 3 and 0. So let's try another one. I'm going to do it at negative 16 now. You'll notice my solutions are at negative 4 and positive 4. If I do one more here, I'm hoping you can predict out if I did 25, it shouldn't surprise you to see that our zeros are at 5 and negative 5. So the way that we're solving that one, it involves the shortcut, if you will. You can solve using square roots by recognizing that you have no middle term, so we have no x. We just have an x squared equals another number. And the solution is really simple. So we just take our x squared minus 81 equals 0. And we set it in this form. So we're going to move the 81 over to this side, and we're going to be left with x squared equals positive 81. Now, the solution to this, we know that to cancel an x squared, we just square root both sides, and we're left with x equals 9. Now, don't make the same mistake I made. Make sure you remember that there's both a positive 9 and a negative 9. Now, it shouldn't surprise you at all to see, let me see if I can quickly get back to my Desmos. There we go. Then if I put this one in, 81, you've already told me by the graph that this is at negative 9 and positive 9 is where it's going to cross that axis. And there we are right there. At 9 and negative 9 are those intercepts. Okay. So that was a long video. I left you a little Star Wars joke here. I'm a big Star Wars fan, if you didn't know. And so I left you a nice little Star Wars meme there. When you're getting ready for this quiz, there's quite a bit in there, but it's not as difficult as you might expect. I'm going to upload a couple more practice videos, especially on how to graph the equations and find the axes and things like that. Do your exit or your entrance ticket, and then you'll be ready to take the quiz. Okay, guys, have a good time.